So yesterday we started to talk about these things called an independent and a dependent variable. So I just want to get some more detail about those things. When we talk about a controlled experiment, we're really talking about a comparison of different variables. And those are the independent variables that we have. Okay, so I'm going to use a pretty common example, and that's when you take a plant and you are trying to add something to that plant in order for you to see if it grows or not. Okay, so we're going to start with plant A. You're going to see some of my amazing artwork here. So here we have plant A, and there's lots of stuff that we know about plant A. We know that plant A is a specific type of flower. We know that plant A is in a specific type of pot. We also know that plant A has a very specific type of dirt. We know that it is getting a certain amount of sunlight. We also know that plant A, this is my best attempt here at a watering can, is getting a certain amount of water every single day. Okay? Now, we're going to treat this as our control group. What that means is this is our normal group where we're not going to have the independent variable at all. This will not change. So everything that we just listed is a control. It's the same amount of sunlight, it's the same amount of water, it's the same type of plant, etc. Now what we get is our experimental group. And when we set up an experimental group, everything about it is exactly the same except for the independent variable. So if this is group B, in group B we have a plant that's in the exact same type of pot, it's the exact same type of plant, it's getting the exact same amount of water, it's getting the exact same amount of sunlight. So everything in there, everything in this group is a constant. It's the same between both groups. The only thing that is different that we would add is the independent variable. So I'm going to say for this one that we're going to put in some fertilizer into this one. So that fertilizer goes into the soil, and we're going to say that the fertilizer makes the plant grow taller. Okay? So in this case, the fertilizer would be the independent variable. And to see if the fertilizer actually works, we have to measure something. And in this case, we're going to actually measure the height of these flowers. And since the height of those flowers is in relation to adding in that independent variable, that is going to be our dependent variable. Okay? So, again, just a review, we have two types of groups here. We have our control group, which has all of our constants. They're all the same, and it is without the independent variable. We have our experimental group, which again has those same constants. Everything is exactly the same, but this group actually has the independent variable in it. Both groups also have the dependent variable because both groups have to have that measurement piece in order to see if that independent variable is actually working. So I'm going to demonstrate that again, but we're going to do it a little differently this time. What I'm going to do is I'm going to actually record this without a control group. I'm just going to do a comparison of two things and talk about the independent and the dependent variable in those things called constants. So in this case, I have two basketballs. I don't know why I started on this side, but I did. We're going to have basketball A and basketball B. And what I'm going to say is that I want to know which one of these two basketballs will bounce better than the other one, okay? So both of these are experimental groups. We don't actually have a control group in here because we know through experience that if I don't drop a basketball, it doesn't bounce. So we're going to exclude the control group in this situation. But I do need to have constants. I can't take basketball A and I can't underinflate it so it's only, let's say, at 5 psi, and then inflate basketball B to 20 psi and drop them, because that definitely is going to cause basketball A to not bounce as high. I also can't take basketball A 20 feet in the air and drop it and drop basketball B from a couple inches. Those both would change the variables and would definitely have different results than what we're looking for. So I have to come up with some ways to make these two things have the same exact constants to see if actually one of them bounces better. So here are a couple things that I could say. I could say that I could devise a contraption that's going to hold these basketballs, and when I push a button, it's going to drop these basketballs from a distance of, let's say, 10 feet. I can also say that we're going to inflate both of these basketballs to 20 psi. And we know, just because I said that these contraptions are both the same, that they're going to be dropped exactly the same way. Then what we'll need to do is measure how high both of these basketballs bounce, and that type of measurement will also have to be done exactly the same way in order to make sure that we're not adding multiple variables. Okay, so now we drop them, and because we've taken care of all of those constants, then the results should be solely based on how well those basketballs bounce. So if we do see a difference in our dependent variable, and again that's going to be how high they bounce. If we do see a difference, then that will tell us that one basketball actually bounces better than the other. Okay? So again, a review. In this case, we don't have a control. Both of these are experimental groups. The type of basketball in this case is the independent variable. That's what we're changing. We are measuring the height of how high the basketball bounces. That's our dependent variable. And our constants are these things that we're keeping the same in our contraption here. Those are the things that are the same in both groups.
Key terms from this are: 1. Control group, a group separated from the rest of the experiment where the independent variable being tested cannot influence the results. Experimental group, a subject or group of subjects in an experiment that is exposed to the factor or condition being tested. The independent variable, the experimental factor that is manipulated, the variable whose effect is being studied. Dependent variable, the outcome factor, the variable that may change in response to manipulations of the independent variable. And constant, a variable that cannot be changed or is purposefully not changed during the experiment.